This project will determine if there is a correlation between low income and fracking well locations. Hydraulic fracturing or fracking is a technique used to extract oil or natural gas deep within the ground. It requires the injection of about 1 million gallons of water, toxic chemicals, and sand at high pressure to create fissures in the ground. Once the fissures are created, fossil fuels can come out from the well and be collected. Fracking allows the U.S. to meet growing energy demands, but it has a negative impact on health. This list consists of a few of the negative impacts on public health. Increased health risks are observed if communities live within a 0.5-mile radius from a fracking well. Children are more vulnerable. Higher risks of respiratory complications and leukemia have been observed. All chemicals used in fracking are not publicly available, which leaves gaps in studies. It is difficult to look for trends in diseases caused by fracking without this data. Students attending an elementary school in Kern County, California, can see a fracking well site from their school and have complained of respiratory issues. Air quality conditions can be so poor that children are advised to play indoors. Children are more vulnerable to health risks in comparison to adults and are at higher risk of developing respiratory complications and certain cancers. Low-income communities are often impacted when it comes to environmentally damaging activities. It's crucial to determine if income plays a role in determining where fracking activity takes place. The EPA's definition for environmental justice includes the fair treatment regardless of race, color, national origin, or income. Low-income families have earned their fair share of environmental pollution, and now their children are being impacted. My objective in this study is to determine if fracking well sites are located in areas of low income, and to determine which schools are most vulnerable from pollution from fracking. This analysis will analyze median household income data at the census tract level in relation to fracking sites, and use free or reduced price meals information from schools as an indicator for poverty to determine if fracking sites are located in low-income regions. In addition, the most vulnerable schools to fracking pollution will be identified. The steps used to answer these questions will be addressed here. One way to determine if low-income families have more fracking well sites near them is by using median household income data from the Census Bureau. The first step I took to begin this analysis was to merge the fracking wells located in California, and then to select all hydraulically fractured wells. Household median income was then joined to California shapefile to display income levels. The second method to determine if fracking sites are in regions of lower income uses free or reduced price meals data joined to California kindergarten through 12th grade school centroids. Free reduced price meals can be used as an indicator for poverty. I created a multi-ring buffer of 5, 10, and 15-mile distances and intersected the buffer with the schools to see if there are more students eligible for this program the closer they are to a fracking well. Lastly, I created a multi-ring buffer, again, to analyze which schools are within the 0.5 and 1.0 mile region around a fracking well by another multi-ring buffer. I intersected the schools with the buffer region and created a table. The choropleth map on the right displays median income in relation to fracking points. By intersecting hydraulic fracking points with household median income, I calculated that the average household median income where fracking occurs is $48,808. The Census Bureau stated that the California state median household income in 2015 was $68,500, meaning that fracking points are located in regions of lower household income than the state average, putting communities in these regions at higher risk of being impacted by pollution. The table on this page displays household median income by county. Next, I evaluated the results from the free reduced lunch program joined to the school centroids within the 5, 10, and 15-mile buffer region. I calculated the number of students eligible for this program in each of the buffer regions and divided by the number of total students within the 15-mile region. The figure on the left shows the results for this analysis. An increase in eligible students for the free reduced lunch program is seen at the 10-mile region. These results did not showcase a strong trend in fracking sites being located near schools with students who are eligible for the free reduced lunch program. Lastly, I wanted to determine which students are attending schools within the 0.5 and 1 mile distance away from an active, idle, or new fracking well. Children attending schools within 0.5 miles from a fracking well are more vulnerable to pollution from fracking, while those 1 mile away are at moderately high risk. Policies need to consider having buffer regions around wells so children attending kindergarten through 12th grade schools and communities are not directly impacted by fracking pollution, no matter what their income level is. I would like to thank the G-Cell team, Professor David Zaw and Megan Danielson, for all the help they gave me with this project.